Here we will show you how to change the firmware of Tuya Relay using BK7231. This will allow us to free it from the cloud, from the manufacturer's servers, and connect with other ecosystems such as Home Assistant. The process shown here will be quite interesting, as it will require you to cut one track on the PCB and remove one capacitor. Not all relays require such operations. We have chosen this one for video because it's interesting. The presented materials were recorded by a friend from the forum. Start with removing the housing, just pry it with a flat screwdriver. This relay is based on the CB2S Wi-Fi module, BK7231N. The board has 3.3 volt LDO voltage regulator. You can see it pinouts on the screen. Power supply 5 volt can be soldered to the regulator input. AX, TX and SIN has to be soldered to the CB2S pads. First, tin the wires. Then, put the flags on the pads. Then, put additional PB solder on the pads. Now, hold the TX wire with one hand and solder it with the other hand. Solder the power supply to 3.3 volt stabilizer pins. As before, flags PB solder wires. Now, solder the SIN signal. Here is our USB to UART converter. It has an additional 5 volt output routed directly from the USB. This USB to UART converter has a gold pin marked 5 volt, but it's not suitable for this. It is used to select the voltage levels 5 volts. Voltage levels are selected as 3.3 volt as BK7231 runs on 3.3 volt. They are selected by the jumper on the blue breadboard. Jumper is between 3.3 volt and VDD. Let's connect our module, leave the SIN signal loose. Then, prepare the second loose wire, connect it to GND. Shorting SIN to GND will reset the system, but remember, it's tricky to do it. Wires must be shorted for a fraction of a second, while programming tool is waiting for getting bus. Now, you would program normally as in previous video about the bulb, but there is one problem. Can you see this PCB track? It's one of programming UART signals, and it leads to the button with a pull-up resistor. It will interfere with the programming. We need to cut it temporarily. See that little capacitor? It is also on the UART line. It's probably here to debounce the button. We will remove it. The bouncing is done in a new firmware in software. Capacitor removed. Now, finally, there will be no programming interference. You can finally back up 2 MB of firmware and upload a new firmware. As in the previous video, use hit download pipe, start flash command and reset module. You have a link to previous video in the description. The only difference is that we reset here by shortening scene to the ground, and in previous video we did that just by repowering the module. After making sure that everything works and OpenBK Wi-Fi access point showed up, desolder the wires. Now we have to fix the cut PCB track. We can make a jumper from an axial resistor lead. Remove the solder mask from the PCB track to be able to solder to copper more easily. Cut the jumper to size, position it, and solder it. After all, clean the PCB from the flags. Now we will show you the pin configuration in OpenBeacon. Configure the pin on which is the relay and the pin on which there is a button. From now on, we can control the relay via Wi-Fi. From now on, we can control the relay both from the button on the device and by the Wi-Fi. On the OpenBeacon web panel, we have a button which, when clicked, allows you to change the state of the relay. OpenBeacon also allows us to pair this relay with Home Assistant, among others. And script it freely. You can read about scripting on our GitHub. Finally, I would like to show you our teardown database. If you have an interesting device, you can make some photos from inside, some photos of case and packaging, and post it on our teardown section. See you on the forum!